Okay, so number 2 and number 3 on the more torque question sheet. Number 2 says a wooden uniform plank of 6 meters in mass, 90 kilograms, is resting on the top of 2 sawhorses. Now, if you're not a farm girl like I am, you might not know what a sawhorse is, and that could hamper this question. Okay, so a sawhorse is a plank that is across like 2 sets of legs. So if someone in your life has like a workshop, you might see this, and there's usually 2 of them because they're used out in the workshop. They're used on the farm that I grew up like this, and then you would put like your board across the top, and that way, like balanced on both of them, and that way if you wanted to saw it or cut it in the middle, you could do that, as opposed to like lying it on a bench or on a table and then risking cutting the table or the bench. When we were kids, we used to take my mother's mop that had like the bushy hair and attach it to the end, and then it really looked like a horse with a mane until she found out her mop was missing, and then it didn't go so well. Okay, so this is what we're talking about in this question. So you're out in your grandfather's shop, perhaps. You found the sawhorses. You take this long board and you balance it across the top of the sawhorses. And then your kid brother Throckmorton, they call him Throcky for short, is out there with you, and you say, "Hey, Throcky, I'll pay you $1 if you see how far you can walk out on the end without it tipping." Okay? So I'm going to just extend this board so you can imagine that perhaps if he's standing out here on this edge, that this whole thing might rotate. Okay, so it's 6 meters long. The full length is 6 meters long. And the mass of the board is actually quite heavy. The mass of the board is 90 kilograms. And it's resting on top of the 2 sawhorses, separated 6 meters is pretty far too. Separated by a distance of 1.5 meters. So this is 1.5 meters from sawhorse to sawhorse. And they're equally distant from the center. And the center would be here, 3 meters from the edge, and this will be FG of the board. Okay? So now it says, your brother Throckmorton decides to stand on the right-hand end of the plank. If the plank is to remain at rest, how massive is Throckmorton? Okay, so this is FG of Throcky. And he's on the right-hand end, so he should be 3 meters from the center, however far from the sawhorses. Now, this question might seem complicated, right? Because there's going to be an F of sawhorse number 1, a normal almost, going up here, and an F of sawhorse number 2 going up here. Okay, so we have potentially 4 torques when we do the sum of the torques, which if it's not going to move should be 0. So the normal from 1, the normal from 2, the weight of the board, and of course the weight of Throcky. But the key is, where's the pivot point going to be? And to understand that, you maybe need to think about what's going to happen as this is about to tip. So Throcky's standing out here on the end. Just need to make it smaller so you can see my whole pin at once. And as this is about to tip, it's going to pivot around the sawhorse that's closest to him. And as it's about to tip, it's going to come off this guy completely. So really, the pivot point is going to be here. And this one is going to do nothing. It's like it's not even there. Okay? And this is so this, no contact. And this will be the pivot point, so the R will be 0. And so now we just have Throcky in the board. The board's going to make it rotate counterclockwise. Throcky's going to make it rotate clockwise, so positive, negative. So R of the board, FG of the board, sine theta of the board will equal minus R of Throckmorton, FG of Throckmorton, sine theta of Throckmorton equal to 0. Before it tips, the angles are 90, the sine thetas are 1, So we'll have R of the board, M of the board, G. Taking it over to the other side, R of Throckmorton, M of Throckmorton, G. The G's will cancel. You're solving for M of Throckmorton. So R of the board, M of the board over R of Throckmorton. Now R of the board is in 3 meters. It's how far is it from the sawhorse that's going to be the pivot point. So we know the FG of the board is exactly in the middle. We know the sawhorses are centered on either side of it 0.75 meters away. So the R of the board should be 0.75 meters. The mass of the board, 90 kilograms. R of Throckmorton, he's right out on the end. And so he's 3 meters from the middle. And if the sawhorse is 0.75 meters from the middle, then this, oops, sorry, get this back on the screen, then this should be 2.25 meters. 2.25 meters. The mass of Throckmorton then should work out to be 30 kilograms. He's just a little guy, and you're bribing him to take his life in his hands because a 90 kilogram board hitting a 30 kilogram person, if it tips, not going to end well. But he'll do it for $1. All right, number 3 on this sheet is a car. Okay, so a car, and I'm going to draw the car, the tires as like 2 fulcrums, and the car like this. And let's call this the front and this the rear. Okay, so it says it reports that certain sports cars have 53% of their weight on their front wheels, which makes sense because the engine should be here. So that means the F normal of the front is supporting 53% of its weight, and the F normal of the rear is only supporting 47. It also means the center of mass of the car is not going to be in the middle. It's closer to the front. It's not uniform. So FG of the car is going to be closer to the front. And it says the wheelbase, the distance between the wheels, is 2.46 meters. And it says, so the normal of the front is 53% or 0.53 W. The normal on the back, 0.47 W, where FG of the car is W. And it wants to know how far in front of the rear axle is the center of mass. You're looking for this distance, this R of, the rear. Okay? You have 3 options of where to pick your pivot point. Here at the rear, here at the center, or here at the front. Easiest would be on one of the 2 wheels, okay? And if you're looking for this, I'd probably pick it at the rear. So I'd probably pick it back here, okay? Because then you can solve directly for this R of the rear. So do sum of the torques equal to 0. A torque from the rear, that'll go to 0. A torque from the weight of the car, and a torque from the front wheels. Holding my pivot point at the rear, the weight of the car goes down, the front go up, so negative, positive. So mine is R of the car, FG of the car, sine theta of the car, plus R of the front, F normal of the front, sine theta of the front equals 0. Angles again are 90, so these will be 1. And you're looking for the R of the car, which is really how far is it from the rear. So take over R of the car, M of, and this FG of the car is really just W. Take this over and look after the negatives. R of the front, that's an F. And this Fn of the front is really 0.53 W. W's cancel. R from the car from the rear is going to be R of the front, the wheelbase 2.46 meters times 0.53. And when you do this, it should end up equaling 1.3 meters. Done.